What we're going to do now is give a more formal definition to a lot of stuff that you're really already used to. So we're going to talk about inputs, outputs, and interpreting expressions. So one of the biggest things that kind of scares people in math is there's this concept of quantities that can change, or you're used to an expression that has variables within inside of it. And this is something that we want to kind of talk about deeper. So in your everyday life, there are things that are constantly changing. The time it takes you to get to school is a prime example. It's not the same on a daily basis because there's a lot of factors that go into it. There could be traffic, there could be bad weather, there could be a rerouting. There's so many other things that can cause this quantity to change. So when it's something that's not set in stone, we often like to assign a variable to it because that variable is indicating this is something that is not always the same. So a variable is a quantity that can change. Okay. So it's often represented by a letter. So always when you're thinking of math, we think of the variable x. It's in a lot of expressions, and all that means is that quantity can change. So it can be replaced by a multitude of numbers. Now, in contrast to that, if you have something that will not vary, that's called a constant. So this is going to be something that's represented by a solid number. It will not change. So you can think of this as something like the speed limit on a certain road. That does not change. It is pretty much set in stone. Or for over a period of time, the gas price is something that's set in stone at any specific location. It's not changing immediately. Okay. Now, what happens though is if we have something that can change, it can depend on some things that are constant. So we often have some kind of relationship relating all of these different quantities. So if we have something that's a combination of variables and constants using some kind of mathematical operations, we call this an expression. Okay. An expression is something that is not equal to something else. So it's just a set stone line. If you have something that involves an equal sign, this is stating two quantities are equal to each other. This is an equation. So I know those definitions kind of seem similar to each other, but an expression is something that's just kind of there. It's not set equal to anything else. Where an equation is going to say, okay, this expression is equal to this other one. So let's try an example. We're going to classify the given thing as an equation or an expression. So what you want to look out for when you're looking at that expression given to you is, does it contain an equal sign? Because all four of these definitely involve expressions because they have variables and constants, and they have some kind of operations like multiplication, division, addition, subtraction, whatever it is. But this equal to sign is telling me that the left side, 3x plus 2, remember that x is a variable, it has to equal 7. So this first one is an equation. Where if I move to the second one, it just tells me 4x plus 2y. Does not equal anything else. This is just somehow relating these two variables, x and y, to these constants. So this is just an expression. So again, this one is not set equal to anything else, so it's an expression. Where here I have one expression equals another. That's an equation. Then if I go to this third one, again, I just have 11 divided by t minus 2. Not set equal to anything else, so this is just an expression. Whereas this fourth one, we have a lot of variables going on, but this tells us A is equal to L times W. Each side is an expression, and we're saying they are equal to each other, so this creates an equation. So what this does in a lot of instances, this last one might be something that looks familiar and is something we're going to go over. It relates different variables. So A, L, W, they're all variables. If you recall this is actually going to give you the area of a rectangle. So the area of a rectangle is equal to the length times the width. But none of those are set in stone, so the area changes, the length changes, the width changes. So they're all represented by variables. Okay. So what we often want to do is if I have some kind of equation or an expression, I want to see, okay, well, in this one particular instance, if my one quantity is equal to something, and maybe if I have more, they're equal to something else, can I figure out what this expression will boil down to? So in this one, we want to evaluate the expression when b is equal to -2 and x is equal to 3. And the expression we're working with is 9b minus x. So again, this expression, b and x are quantities that can change because they're represented by a letter or a variable. We specifically want to look at the instance when the variables equal these numbers. So all that means I have to do is I'm going to replace my variable b by -2, and then I'm going to replace my variable x by 3. So at this point, I can say this is equal to 9 times b, and b we're replacing by -2. And then I want to subtract x, and x is equal to 3. So all I have to do at this point is simplify this expression. So you follow your order of operations at this point because now it's just a bunch of constants. So going through that order of operations, we have to do multiplication first. So 9 times -2 is -18, and then -3. And going through that subtraction gives us -21. Now let's try to build some kind of expression given just some sentence. So each of these, we're going to translate the phrase into an expression. So the first one tells us we are going to take c less than 9. So 9 is our starting point, and I want c less than it. So you have to think of how these words translate to an operation. Less would indicate subtraction. So I'm going to take c less than 9. This will translate into 9 minus c. Because think of if you replace c by a number, 3 less than 9 would be 6, because you do 9 minus 3. So c less than 9 is 9 minus c. In this next one, we want 9 more than twice the number n. So starting with this, twice the number n would just be represented by 2n. You double it, okay? Then I want to do 9 more than that. So once I've doubled the number, I need to add 9 to it. 9 more than twice n. Okay. So just try your best with those. If you see more, it's indicating addition. Less, subtraction. Twice, 2 times. 3 times would be multiplication. Half, you could do as 1/2 n, or you could also do n divided by 2 because you're cutting in half. So every single one of our English words will translate to that operation we want. Now for this next one, we're going to fill in the table utilizing this expression. So we have y is equal to 18 minus 3x. So this is an equation. It tells me that this variable y is equal to this expression I have over here. So these two things can change. The variable x can change and the variable y can change. So we're going to go ahead and we're going to figure out what y is equal to based on these particular x values. So all I'm going to do is I'm going to replace every single instance of x by the value we have in this left-hand column. So for the first one, we have y is equal to 18 minus 3x, and they're telling us that x is equal to 2. So going through with our order of operations, we have to do 3 times 2 first, which is 6, and then 18 minus 6 gives us 12. So when x is equal to 2, the y value is going to be 12. And remember, we can plot that on our rectangular plane. And now we just keep doing the same thing. We're going to replace x by all of these different values. So in this next line, we're going to replace x by 3. So we have 18 minus 3 times 3, which is 9. And 18 minus 9 gives us 9. So when x is equal to 3, y is equal to 9. And then finally, we're going to plug in 5 for x. 3 times 5 gives us 15, and 18 minus 15 gives us 3. So when x is equal to 5, y is equal to 3. And now I can keep doing this as many times as I want for as many different x values as I want. We can do decimals, we can do negative values. It gives a relationship between these two variables. Okay. So let's try one more before we go through and talk about some other vocab. Last week, Hans drove 121 miles. This week, he drove B miles. Using the letter B, we're going to write an expression for the total number of miles he drove in the 2 weeks. So if you're thinking about that just from a normal perspective, if you're trying to figure out how many miles you drove in 2 weeks, you take last week's miles and you add this week's miles. Well, last week he drove a constant. It was exactly 121 miles. And this week it's some unknown, B. So all we're going to do is add these two together. So it gives us this expression representing his total mileage. Okay. Now before we move on to the next part, I'm going to go back up here for a second. What we actually have in this particular equation is the variable y depends on the value of x, because I couldn't find the y value until I knew what x was. So I had to plug each of these values into my equation to find this output. So what we actually say back up here, this x is called the input because it's on the more complicated side of this equation. Y is off by itself. So once I plug in an x, I can figure out what y has to equal. So we input x's, and in the end, we get this output y. Okay? This is going to happen with a lot of equations that we see. Even if I go way back up here to this one that was involving rectangles, the area is depending upon what I input for the length and the width. So L and W are the inputs, and the output is the area. Okay. So when this happens, we say that one quantity depends on the other. So we're inputting this one value. It has no restrictions on it. That's what we call our independent variable. And then we're getting something as an output, and that depends on what we inputted. So independent variables cause changes in the dependent variables. So again, just going back up here, once I changed my x value, it caused changes in my y value. So my input is going to be my independent variable. My output is the dependent. But if you don't like thinking about that just yet, let's think of just some realistic examples. So we're going to identify the independent and dependent variables in each of these cases. So we have the cost of a cab ride and the number of miles that you're driving. So if you think you're hailing a cab, have to go to the airport, that number of miles is predetermined for you. So this is going to be our independent variable. where the cost of the cab ride is going to depend on how many miles you drive. So this is our independent variable, and this is our dependent. So you really can just ask yourself a question or kind of rearrange a sentence. The cost of a cab ride depends on the number of miles driven. That makes sense. The number of miles driven depends on the cost of the cab ride. That's not as clear cut because it would make more sense that we're going to figure out how many miles we have to drive. Okay, this is going to then predetermine or determine what my cost is going to be. Same thing for this next one, the weight of a package and the cost to send it. If you think about the weight of the package, you have to mail that thing. It's whatever weight it is. So in this particular situation, the weight of the package is going to be our independent variable, while the cost is going to depend on how heavy our package is. So this would be our dependent variable. And then both of these are going to change. The weight of the package, if you increase it, it's going to cost more money to send it. If you decrease it, it's going to cost less money. So there's still two things that can change, but once I impact one, it's going to impact the other. So changing the weight of the package is going to change the cost that it will take to send that out. So when we have our expressions that we're evaluating in our equations, we're still going to have the same idea. What we like to call these, though, are functions. So if I have one variable is equal to this other expression involving the other, that's going to be a function. So a function relates the input to the output. The input is going to be our independent variable, which typically is going to be x, and the output is going to be the dependent variable. Okay. So using this equation, u is equal to -3 plus 3z. I can change my z to be whatever it wants, but there's no restrictions on it. So here, this is my input because this is the more complicated side of the expression. So this one is my independent variable. But as soon as I then pick a value for z, that tells me how to figure out u. And if I change z, it changes u. The variable off to its side on its own is our dependent variable. So the main thing you have to really take out of this is if you have an equation or an expression and you're asked to evaluate it at some point, which is something we've already done with a lot of these interest formulas, all you're doing is really replacing that variable by whatever quantity you're looking for. Or if you have to come up with an equation to represent something, you want to use variables in the cases that something is going to be changing.